Okay, so things begin to get tough now. We begin to take this idea of proofs and we begin to put it in with the geometry. And there's one huge concept that makes this different than the other stuff we were doing, and that's the idea of object language versus number language. And I'm going to try to explain that out to you and then give you some walkthroughs on these proofs. As you do them, you want to make sure to take the time to read through the proof, make sure you can translate or understand the symbolic language and what's being written down and how it relates to the reasons, because as you give your narrative, that's what I'm going to expect you to be able to do, all right? If you need to watch this video a couple times, make sure that you do that, all right? Okay, so we're talking about object language versus number language. This is a little bit of a weird concept, but it applies to geometry, so you've got to get a handle on this. All right, so the first thing that I want to bring to your attention here is what we're doing. We've got this given picture to us right here. We're being asked to prove that the measure of angle EBC is 65 degrees. Now, you heard me say measure of angle EBC. That's what that letter M stands for right here. And this is what takes us into number language. All right, so when we refer to the actual specific degree values or the numbers of angles, and we have to actually do math with numbers, we need to transition to number language, and we have to put this M out in front of our angle name. Let me show you the difference. Take a look down here in the actual proof itself. When I say on step number 1 right here, when I say angle DBE, what I'm referring to generically is just this space in here, just that gap. I'm just saying, hey, that space, that gap is angle DBE. Okay, when I want to specifically refer to the fact that that gap is 25 degrees, that it has a numerical value, I need to change from just angle DBE to the measure of angle DBE. That's what allows me to then begin to transition to use math. You can see I'm adding and I'm setting things equal to each other here, because we can't do math with objects. I can't say object 1 plus object 2 equals 90 degrees. What I need to say is the measure of object 1 plus the measure of object 2 is equal to 90 degrees when you add them up. So what you can see is I've used my substitution property here to replace the measure of angle DBE with 25 degrees. All right, now I can do that because I'm talking about number language here. All right, so just a couple of things that you can see here is this transition between object language. There's no M out in front, so we're just talking about the generic space here. And then when we transition to the measure of angle DBE, we begin talking about the actual values themselves, the 25 degrees. And that's what allows me to do the math. That's what allows me to add, subtract, multiply, divide, all of that. Because we do math with numbers, we don't do math with objects. And that's the important concept for you to grab right here. Why we need object language versus number language? We do math with numbers, we can't do math with objects. So in these proofs that you're working on in geometry, there's going to be a lot of jumping from object language to math language or number language, and then eventually we'll probably end up jumping back to object language as well, as you'll see in these proofs. Really important that you try to grab this concept. If it's not making sense, come see me and I will try to help you with it. Now, one other thing I want to point out about the proofs, when you look at the difference between line 3 and line 4, you should notice that I took off 25 degrees from the left side of the equation and I took off 25 degrees from the right side of the equation, leaving me only with the measure of angle EBC, right? Measure of angle EBC being equal to 65 degrees. Now, taking away equally from both sides of the equation, that was the subtraction property of equality, right? But because our proofs are going to be containing a lot more geometry stuff in there, we want to sort of sum all of that up. So all those properties we worked on, the addition property, subtraction property, multiplication and division properties of equality, anytime we do algebra, we're going to, in the IXL lessons, we're going to be wrapping that up with one title called algebra. All right, so that kind of helps us sort of put everything together into one neat category, since that's what our initial proofs were based on. We're based on algebra. Okay, so let's take a look at an actual IXL proof. Okay, so this is an example of an actual IXL proof for angles, and one of the things that I want you to be able to do, again, and I've kind of been stressing this point with you, is be able to make sure that you can tell the narrative story all the way down. You want to be able to tell the narrative story all the way down. I'm going to kind of walk you through it, and I'm going to point out some of that object language and number language as we go along. First off, we've got our statement of given right up here. It tells us that angle S and angle R are supplementary. It tells us that angle R and angle T are supplementary. We know what that means. Again, you can see this is object language, right? There's no M out in front there. And again, you can see that there's object language over here with the angle R and the angle T. Again, so we're just referring to that gaps of those spaces. When we talk about objects being the same, we use the congruence symbol. We don't use equals. Equals are for numbers being the same. Congruence are for objects being the same. And that's, again, that important difference between object language and number language. All right, so here we have our statements being broken down. You can first see our initial two givens. That comes right from the statements up above there. What I want you to do is I want you to see the connection between 1 and 3. Take a look at the connection there. 1 says that object angle S and object angle R are supplementary, and then statement 3 takes that and turns it into number language. The measure of angle S plus the measure of angle R equals 180 degrees. So we're transitioning that from object language to number language. Okay, can you see the difference there? And again, as we look at the statements between 2 and 4, the same thing is taking place there. We've got object language in line 2, and then we transition that to numerical or number language in line 4. And that is done here by the definition of supplementary angle. So you can see, because we know that they're supplementary, that's given to us, then we can say, well, their measures add up to 180 degrees. How do we know that? Well, we know that because of the definition of supplementary angles. Supplementary angles are two angles that add up to 180 degrees. Okay, now there's one other thing I want you to notice from this proof here. First, we've got these two angles that add up to 180 degrees. All right, I want you to see this, okay? So this left side of the equation, let's call that A, and let's call this B. And then let's call this B, and let's call this C. And this is where you're going to see the transitive property of equality come into play. Watch. If A, which is right here, is the same thing as B, which is right here, and B is the same thing as C, then transitive property of equality, which is on line 5 right here, tells us that A is the same thing as C. And that's what took place right here. You can see that transitive property of equality took place right there. Okay? Now, notice what took place between 5 and 6 here. Notice that the measure of angle R was removed equally from both sides of the equation, right? That's our algebra. That was that subtraction property of equality where we removed both of those equally. And then finally, and again, this is where I said in the other video, we're going to transition from measure language back to congruence language. Look, we went from number language to object language, and that's what our proof statement was from up at the top here, right? We said the measure of angle T is equal to the measure of angle S. That means that the object angle T is congruent to the object angle S. We'll continue to work on this, but hopefully that gives you sort of an introductory place as to where to go with it.